Hello, everyone. Oh, sorry, that was a bit loud. Thank you for joining us. And on this session, we want to talk to you about how to build AI agents reliably and efficiently, and how the OpenSearch project can offer you an open source path to doing all the evals and all the observability needed for that. I'm Dotan Horovits. You might have seen me on the keynote this morning, so I'll keep it short. I'm a senior open source advocate at AWS, and I'm also an OpenSearch ambassador and also a CNCF ambassador, and I also run the Open Observability Talks podcast. That's amongst other titles. And with me is Megha Goyal, who is a senior developer at AWS OpenSearch and also a maintainer at the OpenSearch project. So what is OpenSearch? OpenSearch is, in essence, an AI-powered open source platform for AI-powered search, observability, and analytics. It's a top-level project under the Linux Foundation, and the OpenSearch Software Foundation under the LF is meant to foster the open governance and open collaboration around the project. As you can see, many organizations such as Uber, SAP, IBM, and many more have already joined the foundation and are helping us steward together the future of the project. Actually, quite exciting, just last month, a bit over a month ago at OpenSearchCon Europe, that was held this year in Prague, CERN joined as a member of the foundation. It was a pretty cool story to hear how OpenSearch helps run the world's largest particle accelerator here in Europe. Just out of curiosity, who knows OpenSearch here in the room? Okay, we have and who uses that for log analytics, for search, for observability other than log analytics, broader observability? Okay, we have a few. Nice, super cool. Come afterwards. I have some stickers for OpenSearch. I'll give you the others that don't use OpenSearch yet. Maybe they'll give you an incentive. So come after the talk. And so, how do people use OpenSearch? So as you saw from my questions, there are several use cases. These are the main ones. First, OpenSearch, as the name suggests, is at its core a search engine, providing highly scalable and performance search functionality for things such as your e-commerce website search or your enterprise search, catalogs, and things like that. It's also widely used for log analytics and observability use cases, which will be the main focus for today's talk. Also for AI ML powered applications and for security, for security analytics. So as I said, focus today is observability, so let's dive into that. On the observability front, you can use OpenSearch to do the classic things: detect, diagnose, remedy issues in your infrastructure, in your application. There are lots of functionality around log analytics, such as discover, dashboards, log tail, log surround, log patterns, all of these things. You can also query your data with Lucene, with PromQL for the time series data, for the metrics, with PPL, piped processing language, and also natural language querying is also supported. You have distributed tracing, APM, SLOs, a lot of things around observability. Since we're in Cloud Native Summit, worth mentioning, it's OpenTelemetry native. You have OTLP support, end-to-end semantic convention support, and all of that. It supports Prometheus also as a first-class data source, so you can actually visualize your metrics from Prometheus in OpenSearch dashboards. You can trace agentic workflows and also do developer lifecycle agentic development with evals and observability, which brings us to the topic of today. But before that, how do you get started? The best way to get started with observability and OpenSearch is the observability stack, which is in essence just our one-click deployment, purpose-built for observability. So it deploys a fully functioning stack that you can see here with an OTLP endpoint for your telemetry, with web UI endpoint, with pre-configured dashboards, all the things that I mentioned, APM, agent tracing, everything I covered, all included. And it can be deployed locally with a Docker Compose or on Kubernetes. You have Helm, you have Terraform, very easy to set it up. As you can see, a one-liner command can get you started very, very easily with the observability stack. And now I want to talk about development phase and developing AI agents. So you might have heard me on the keynote. You know the feeling. You got an agent, and most of the time it looks great. Confident, fluent, sounds great. But did it actually do what it was supposed to do? And was that a fluke of luck, or was that really intended? And as I mentioned again on the keynote, it's non-deterministic. So you run the task twice, you get 2 different answers. And then you tweak your prompt, you tweak your skill maybe, and you're not sure, did I get better, did I get worse, where am I? So how do you keep improving reliably, and especially at scale, when you have hundreds of runs that you need to do during development phase? And how do you automatically catch regressions in your agent before they hit production? Okay, you used to do that in software. Now we need to do the same with agents, but how do I do that with agents, and how do I automate that? These are the challenges for today's AI agent developers. And I want to hand it off to Megha, who is herself an AI agent developer. She has a few already under her hands, and she can share the use case and how she used to work and how she made it better, and also how OpenSearch and Agent Health helped her in that journey. Megha, the stage is yours.
Answers and understand how do we, reach the bar of actually shipping this in production. Then came phase 3. Phase 3 was about hardening the agent. We soon hit a plateau with all of our improvements, and we really needed to understand how do we make further improvements. For that purpose, we started adding these benchmarks, some metrics, and doing manual spot checks to understand where we can, bridge the gap. Then came phase 4. That was all about making it ship, having guardrails in place, making sure that our CI workflows were catching the right regressions. And this required us to add another test runner specifically for just our evaluation benchmarks. All of this work was independently taking a lot of time, and all of it was sequential in nature. That's where the months went. So, what do we do in this situation, right? To address these challenges, we built OpenSearch Agent Health. It's a lightweight open source developer tool that allows you to ship agents reliably. Agent Health helps you on every step of the journey. It helps you understand how do you curate the right benchmarks, run and compare them with other competitive agents, and also compare the agent's own trajectory and understand how your agent is doing over time. With Agent Health, you get to curate the right test cases with our rich SDK, a headless CLI to help you run these as part of your CI/CD workflows, and use the UI to actually dig deeper into your observability data as and when needed. You don't need to switch to different tools anymore. You get everything in a single place. You have observability, you have evaluations, and your token cost calculations. Everything baked into a single place, all because your data is backed by OpenTelemetry. So how did we do it differently this time? About 2 months ago, I was tasked with building another on-call agent for understanding and improving our ticket workloads. And I want to take you folks through that journey of how we ended up building this in a matter of weeks instead of actual months. I decided to this time use Pi and Claude Code as my agent harnesses to build my agents and use this as a baseline. I instrumented both of them with complete agent outputs, and right now I'm running them on my local instance. So what exactly did Agent Health help? I have a local, okay, yeah. In the meantime, I have a local agent health instance running on my EC2. Yeah, we'll just, okay, so it's loaded. So this is right now running locally on my EC2 with my OpenSearch cluster attached to it. It's storing both my observability data as well as my evaluations data. So exactly what does agent health do? You get to understand in detail what is happening inside your agent. So right now, this is a run of my Pi agent where I asked like a simple question some time ago. And you get to see the sequence of events that actually happened. You get different views and understand exactly what's going on. And because this is using open telemetry, you get to understand the same things with the same generic attributes. You can also see optionally the agent output. Because this is running locally, I wanted to see all of it. Okay. So back to our agent, right? We wanted to create an on-call agent using either Pi or Cloud Code. To understand this better, I instrumented both of them, and I used a single task where I wanted to find redundant customer APIs inside my own agent health code base. For this purpose, I ran one very simple task and, sorry. So here, you get to see the test case output. You get to see the traces which are attached to it. You also get to see the judge evaluations. I'll talk about this in like just a second. Judge evaluation helps you actually rate your actual test case and see whether it's actually performing well or not. You get to put in your judge evaluator criteria where you can provide the exact details specific to your agent, your scoring metrics, and understand whether it's actually meeting the bar or not. You can put in both deterministic matchers like latency checks or like understand whether the agent's output is exactly how you expected. And then you can put in some judge evaluations where an LLM judge will actually score against your own rubric and understand whether the expected output actually matched your actual output there. And of course, you have annotations for human in the loop. We'll use this in just a second. So going back to our phases, right? In phase 2, I wanted to actually understand whether this particular task was executed correctly by Pi and Cloud Code, and I also want to see what are the actual differences between these two harnesses. Here comes a comparison view. It's the same task that I ran against both these agents with my evaluation rubrics to see exactly how the agent performed, what all traces did it emit, and whether the judge evaluation criteria met or not. Both the tests passed, so this should be fine, right? But no, that would not be the case. This is not very useful information because I don't know which one to choose yet. That's where the AI summary comes into picture. It actually tells you the nuances of both the agents and help you understand exactly what was the difference between the two harnesses. It uses some rubrics like tool economy, investigation style, and LLM strategy to help you get the detailed insights on it. But the agent can always hallucinate. So what do? At that point, you need to back this data by verifiable evidence. And our evidence is the trace. So we want to actually understand whether this line that Claude Code made a single bash call with 11 reads, whereas Pi decided to do 3 strategic bash commands and reduce that time, reduce the number of reads there. So, is it actually true? Let's find out. Each link that was provided in the AI summary will be backed by a span. This tiny sliver, this tool call, is basically that particular span. Let's actually see if it's a bash call or not, right? Tool name, actually a bash call. So this gives you the ability to understand whether your agents are actually performing well or you are just hallucinating that they are performing well by passing your tests. This is the difference between the two agents. You can actually verify your own telemetry and get deeper insights into it. One more thing that I wanted to share, in one of these summaries, I also found out that Cloud Code had like an issue and it decided to fall back on Opus 4.6 instead. So these are the nuances I would never know, because digging into these hundreds of spans manually is really hard. So you do need some sort of processing on your outputs and get these kinds of evidences, which you can always question and always see a verifiable evidence against it. So back to our 4 phases. The third phase was about hardening the agent. At this point, we decided to graduate these test cases into full-blown benchmarks and use the versioning feature to keep on iterating and adding on them. As you can see here in V8, I added a new test case. And all of your tests will live right next to your code base using our SDK. So you don't need to keep any of the data anywhere else. You are the owner, and you get to keep your test cases similar to how you have integration tests or your unit tests. Before I wrap up the demo, I actually want to show you folks how easy it is to run this. So this is running on my Mac, and there you go. Just to get started, we have some demo data. Please go try it out.
All good? All good? Are we?
I hope so.
No, it needs to connect. Everything's okay.
Yeah,
Just want to. Here we go.
thanks. So these were just some of the functionalities of Agent Health. From our 4 phases, you get agent traces, comparison views, AI summary, judge evaluators, and a CLI to run them periodically. However, Agent Health does a lot more. You can wire these evals straight into your CI/CD workflows and actually understand where your agent is getting worse or facing regressions, and fail the build just like a unit test. The judge is also pluggable. You can bring any model from any of the proprietary LLM providers like Bedrock, Anthropic, OpenAI, or even bring your own judge model. Apart from that, the judge evaluators help you stitch the evals together with agent's own traces into a single timeline and judges it based on your evaluation criteria. And on top of it, it's agent agnostic. You can bring in code. You can bring in Cloud Code, Pi, Kiro, LangGraph, or your own custom agents. We achieve this by providing some inbuilt connectors that allow you to communicate with the agent with open protocols like AGUI, REST, CLI, or you can always write your own custom connectors. The QR code points to our tech docs for Agent Health. Please check it out. And quickly, where is this headed? Today, you've got trace-grounded evals, your comparison, the SDK, and the connectors. Next, we are adding online evaluations where you get to score live sessions, not just batch runs, and closing the loop. So it can propose the fix to the agent itself and prove it by running the agent on your behalf. Further out, this lives natively in OpenSearch dashboards for your collaboration needs. This QR code points to the complete roadmap on GitHub. Please check it out. And with that, back to Dotan. Thank you.
Thank you, Megha. Great stuff, and that was about agent health. But in fact, the OpenSearch platform has much more than just agent health for the agentic enthusiasts over here. So I want to touch very briefly about the rich agentic AI framework that you have for running agents both locally as well as external agents. So OpenSearch has multiple built-in agent types, ranging from simple sequential flows all the way to plan, execute, reflect type of multi-agent flows. The portfolio is really versatile, so it's suitable whether you do things such as RAG, retrieval augmented generation, root cause analysis, chatbots, research, whatnot, pretty extensive. It also, as you can see, the blue box there in the middle, offers agentic memory that offered you both short-term, like session memory, and also long-term cross-session memory that grounds the agent with relevant context and learning from the previous discussions, and also a suite of tools that the agent can invoke. And I wrote a whole blog post about the agentic framework, so if you scan the QR code, this is a whole deep dive into the agentic suite that I just described. Also, OpenSearch v3 introduced native MCP support, model context propagation, model context protocol. That's sort of the open protocol that standardizes the communication between LLMs, data sources, and tools. So you have that out of the box as well with OpenSearch. There's a lot more with OpenSearch v3. Actually, we've just last month celebrated 1 year since 3.0. So I wrote a blog post celebrating the 1 year and tried summarizing the highlights of all the 3.x line in the past year. So if you want to get a glimpse of the highlights, you can scan that and see my Medium with the highlights of v3. And where can you find out more in general about the project, about the community? So of course, on the GitHub org under OpenSearch-org -project, we have a very active community Slack instance that you're welcome to join. I'm there, Megha is there, and many other maintainers, contributors, and fellow users. And also, in person, if you want to meet fellow folks using OpenSearch in person, you have user groups all around the world, all around Germany. Even here in Munich, there's an OpenSearch user group. In fact, this evening, there's going to be the meetup of the Munich user group. If you're interested in joining and hearing more lectures and having some beer and pizza and whatnot served there, you're welcome to join. And there are many, many other resources. So I actually have my own curated list of useful links and that I curate. So if you scan this QR code, you'll get all these links in one place. And also lots of other stuff like the roadmap, like live playgrounds. We have a live playground that you can actually play with that without having to install anything, the tech docs, and many, many other things. So, and maybe one more point for how to get in touch and get involved. I think one very great initiative that we had is tags, technical advisory groups. I'm fortunate to be a lead for the observability tag, but we have also a search tag and a security tag and others. So this is a great way to get involved, see where we're heading as a community, and also even help us steer the future of the project together. So if you want to get even more involved, the tags they have open Zoom calls monthly, and also on the Slack. Great place to get into the discussion. And of course, Megha and I are here today and tomorrow. So you have the QR code with all the links on the right-hand side. And please don't forget to leave feedback to the organizers on our talk and rate the talk. That's the link on the left-hand side. I'm Dotan. This is Megha. Thank you very much for listening. And we have 5 more minutes. We made it short deliberately so that we'll have some time, because I'm sure that this triggered a lot of interesting questions. So we kept it short. Please go ahead and give us some interesting questions to make it more interactive. Who's the brave person? I'll give you a sticker. 2 stickers. Yeah, go ahead. Just here's the mic, so you can hear you, and also on the recording.
Hello. One question that popped into my mind since you were comparing Pi and Claude Code is, in your experience, how much of a difference does the harness make, and how much of a difference does the model make? That's my question.
See, I think that's an iterative process. Like we started with like some 4.x version of like the Claude Code models, right? Like over time, the quality of output will always improve. The problem that we are trying to solve here is to actually help you understand the differences and the nuances there. Whether you decide to choose Pi or Claude Code will definitely depend on your use case. For us, I felt like Pi was better for us because it was doing a smarter search, in my opinion. So how agent harnesses like make a difference would depend on your use case. About models, like I would say, like I'm trying to use these models every day, and like the quality keeps on improving. So I have stopped placing my bets on models anymore because the costs there are kind of, manageable, or like they will always decrease over time. So like the harness question will become very interesting when you're trying to solve your specific use case.
And I will add maybe on top of that, very interesting, when you use that tool and you open this black box and you see internally, that it's interesting to see that the different strategy, there is no good or better or worse, because it really depends on what trade-offs you're doing and what weight you put on each factor. But for example, you see that one of them is shorter in terms of like performance, or maybe less costly, but the other one is thorough and it makes extra steps for verification. This one uses bash calls. I think you saw that also on the example that Megha showed. And this one results to simple reads from local files. So it's really different trade-offs. And are you more on the thoroughness? Are you more on the efficiency? Are you more on the cost? So, but you get this opening up the black box and seeing these trade-offs and deciding what's important for you based on this. So this is the beauty of observability here. More questions? Here we go. Don't forget to come for the stickers.
Thank you. Very interesting. I have a small question regarding the pricing, the costs of the estimation for the agent actually running. So I've seen that there is some kind of prediction. The question is, how flexible is it? Where does it get the prices, token costs? Does it include cached tokens? I mean, how can you go between multiple different operators?
Got it. So I think that depends on how you are instrumenting your agent, right? Like the cost calculation will come on based on your observability data. Today we don't provide like overrides. For example, like you may have like a certain pricing with your LLM provider. That we don't have. Like feel free to provide us this kind of feedback that we'll keep on adding in our roadmap. But today you get this based, like the cost will be based on how Anthropic or OpenAI is publishing based on the tokens. So yeah.
And maybe
the cached tokens, this is kind of the thing. Is it including the cached tokens? So because
yes.
If you have a round trip of a request.
But wouldn't that depend on how your agent is emitting that data, right? Like the cache will be present inside the agent's implementation. So whether Pi or Cloud Code decided to expose that token cost to us.
Yeah. Thank you.
Yeah.
Interesting.
The cost is actually on the LLMs, right? It's not because you have the agent cost. It's actually the invocation of the LLM. So the caching optimization and everything that the agent does. By the way, interesting feature idea too, if you have other associated, because I know API calls that have specific additional cost that is not the LLM or other things can also be quantified if you relay that observability data. So interesting points to actually discuss on roadmap.
Sounds good. Yeah.
Here, we have a question over here. The gentleman with the blue shirt.
My question was, in terms of pricing, you see things like Splunk having been established for a long time, and my curiosity is, have you seen a greater shift from solutions like these towards open telemetry in the recent years? And if so, how large was that shift? Or is it still ongoing?
Well, it's a bit off topic for the agent AI and everything, but I can tell you that first of all, Splunk is a major contributor to the open telemetry project. To give them due credit, I think one of the biggest, maybe even the biggest, definitely at some time. So that's as individuals part of the project, open source, being also a CNCF ambassador. Where do they stand on the roadmap? I'm not an authority to say. I'm not a user of Splunk, so I can't tell you where the roadmap and how deep they integrate. I can tell you as a general trend that we see all the vendors aligning with open telemetry. Some of them speak out loud and say we are open telemetry native even. But even those who don't and still maintain their own agents and their own proprietary pieces, they definitely align to certain degrees with OpenTelemetry. So that's why I'm saying it's pretty much a de facto standard, definitely now that it's a graduated project under the CNCF as of last month. So it's broader than just a specific vendor, this or that. I would suggest you engage your account manager or not if you have a specific user. But I can tell you that the pressure has come from the users. So like even those who didn't really want to do the shift got the pressure from their own end users saying, we want OpenTelemetry support to send you telemetry over OTel, OTLP and so on. And then they shifted. So I think this sort of discussion between the users and the vendors is shifting all the direction towards OpenTelemetry. That goes to the traditional logs, metrics, traces. What I mentioned, not now, but in the keynote, is about the Gen AI side of things, the Gen AI semantic convention, the Gen AI SIG, the special interest group, where we already start seeing things such as, you had open inference and you had the open LLMetry and you had other pieces. Each one invented their own semantic conventions and attributes and data models now aligning with the Gen AI semantic convention. So that's the trend that I see. This is already out of the box, already aligned with Gen AI semantic conventions, but some of them that already had something pre-existing are now shifting towards it. I hope I answered the question. Sure. We still have a minute or two. Any other questions? Happy to take. Even if it's broader, I don't mind, Yeah, we have another one here, there at the back.
Maybe I didn't pay enough attention, but this agent health was really cool. If tomorrow I want to use this agent health, how difficult or easy is it to integrate it in my Claude Code or XYZ? But let's say Claude Code, since probably it's mostly used. Yeah.
So for Claude Code, what I did was there are some flags that are provided that you can use to start your Claude Code sessions. What we do is, you get to provide these details in agent health config file, and you can explain how to, hit your agent API. So in case of Claude Code, I am basically launching a sub-process with the right flags that will emit my telemetry to my OTLP endpoint, and that's how it's getting routed to my OpenSearch. Once this goes through, I showed you the npx command, right? All you have to do is just hit that. And for now, what we are doing is we are accessing the Claude Code's SQLite database, I think, that is right now, basically it gets created as and when you are running Claude Code. So we are accessing that data to show you basic details out of the box. Once you add your traces and spans, you'll be able to see exactly what I was showing you today. Yeah.
And the beauty, again, in terms of the specifications, we tried to make it open-ended. So as Megha mentioned, AGUI, sub-process, REST. So it's very easy to plug in whichever harness that you choose. And also even custom connectors to something that is very, very abstract from the standard. So very, very flexible in that regard. Any other questions? One last question? We don't have time. Sorry. Thank you so much for staying with us. Thank you.
Thank you.